Hello class, in today's lecture of terminologies and the band gap determination by UV spectroscopy, let us first come to the terminologies that are associated with absorption. So in this, the first terminology is radiant power, that gives us the rate of energy of radiation reaching to a given area in a second, and it is given as P. The second one is the transmittance, which is the ratio of the transmitted and the incident powers, and it is denoted as T is equal to P by P naught, where P is the transmitted power and P naught is the incident power. The third one is the absorbance, that is also known as the optical density, and it is inverse of the logarithm of the transmittance given as shown in this equation. The next one is the absorptivity. It is denoted as the absorbance if it is divided by the product of concentration of the solution in grams per liter and solution path length in centimeter. The dividend is known as the absorptivity, that is given as small a, and it is equal to capital A by BC, where B is the path length and C is the concentration of the solution. The next one is the molar absorptivity, which is denoted as epsilon, and it is the product of absorbing and molecular weight, which is given as A and M. The next one is the path length. It is the internal thickness of the cylindrical cell in which the test sample is taken. Further, it is the slit width, that is the distance between the entrance and exit of the light in a monochromator, and it is referred as the slit width. The visible light, we all know that it is suitable for the human eyes, and it is falling in the range of visible spectrum. So it is the radiant energy to which the human eye is susceptible and is known as the visible light. Now there are some laws that are related to the absorption. The first law is the Lambert's law or Bogart's law. This shows us the rate of decrease of the radiant power with the thickness of the medium and is proportional to the power of the radiation, that is given as minus dp by dx equal to kp, where p is the radiant power at any instant x in the absorbing medium and k is the constant characteristics of absorbing medium and wavelength of the radiation. The next law is Beer's law, which shows us the rate of decrease of the power with concentration of the absorbing species and is directly proportional to the intensity of radiation, which is given as minus dp by dc is equal to k double comma p, where c is the concentration of the absorbing species and k double comma is the constant characteristics of the system. Next one is the combination of the Lambert-Beer's law, that gives us the combined effect into a single relationship, and that depends upon the thickness and the concentration. Mathematically, we can see that it is log to the base 10 P naught by P is equal to ABC, which is in terms of P can be written as P is equal to P naught into 10 to the power minus ABC. This ABC is having absorptivity, thickness in centimeter and concentration of absorbing medium respectively. Now if this concentration is given as gram moles per liter, then the equation will change to P naught by P is equal to epsilon BC, where epsilon is the molar absorptivity, and when we place the value of C is equal to 1 grams moles per liter, then equation will change to P naught upon P naught by 10 is equal to epsilon BC, with the left hand side as the log to the base 10 when we put the substitution of P as P naught by 10, and on solving we get the molar absorptivity as 1 by V for C is equal to 1 grams moles per liter. So this was about the laws related to the absorption. Now what does this absorbance and transmittance spectrum says? This spectrum says that whenever we are having the absorbance versus wavelength spectrum, in that at a particular wavelength where the maximum absorbance is received, at that maximum wavelength the particular value is called as the lambda max, and that maximum absorbance will give you minimum transmittance. So this was about this small note. Now we will come to the band gap determination by UV-based spectroscopy. This is basically depending upon the thickness of the sample, and in this, whenever a particular wavelength of the light falls, the electrons are moving to the excited state. The theory is this, that if the electrons are moving toward the excited state, then there is a band gap of the sample. So in this, what we do, we receive the absorbance and the wavelength graph, and we take that area whose band gap we have to determine. We have to take that particular wavelength, and that where the maximum absorbance is obtained, and that particular wavelength is substituted in the equation, whether the transition is direct or indirect. These are the two equations which are showing the equations for the direct transition and the indirect transition. For the direct transition, this value to the power is of 1 by 2, and for the indirect transition, the value to the power is of 2. So whenever we get the wavelength value for the maximum absorbance, we substitute the value, and that particular wavelength will give you the band gap. So this was about the determination of the band gap by UV spectroscopy. This completes your unit 4. All the best for test. Thank you.